Hey there, welcome back. I'm Daniel Markham, and what we're working on now is easyam2, which is an analysis compiler. We're on episode 3, and we did a little bit of coding last time. We're going to keep coding every time. So let's talk about what happened in the last little 4-hour chunk of work that I did. You can see on the screen here, the stories I was working on basically was process files without doing anything, and process files and concatenate by file name. First few stories, super easy. That's the way we want things, because the first few stories we're working on meta issues, which is how we work together. And once we get that nailed, we're also working on framework issues, which is how fast we compile stuff, all that stuff. So this is what we're really working on. So basically was you take a file, just give it back to me, and take 2 files and stick them together. Okay. That's where we are. That's what the stories are for. First thing I had to decide on was should I use bash for testing, or should I use expecto? Should I do unit testing inside the code, or should I use an external shell command? And normally this wouldn't be a question at all, but the thing is here is that this is actually what I expect the code to do from the outside. This would be, the very, very outside of the shell here. And so it kind of makes sense to do it from bash, because if the program's returning perhaps an extra line or two that shouldn't, it could be that the unit test would work fine, but the bash, the outside for the user, would actually fail. So I decided, yes, for both of these stories, was going to write 2 sets of tests. First would be a bash test that would check it. You could also call that a smoke test, because it's basically asking, if I send you nothing, do I get nothing back? And if I send you a couple files, do you stick them together? And then the expecto tests, which are my first real tests, ask the same question, but this asks the question of the libraries instead of the executable. So we started rock and rolling here. There's my stories. We go over to the EA folder. EA is the executable for the compiler inside the program FS. I've reduced the number of opens here, which is yay. It doesn't have the ugliness it had before. Down here, starting about line 29 or so, I have incoming file stream. And so for this to work like Unix, it has to take a piped in file, which turned out to be quite a gnarly little exercise. Different consoles, the Git Bash console, the Ubuntu console, the DAWS console, actually handle piping and characters differently. And so I ended up actually working on these tests right up until the last moment, which I wasn't expecting. I was expecting to work on them and then tweak a little bit. But that was fun. I learned something, and this code should be useful for folks. So basically I do a 3-part check here to see if I have input redirected, if there's key available, and if there's anything in the buffer. Each of these has its own problems in its own environment. It works in one, doesn't work in another. It was lots of fun. So I did put a try around them all, and if you fail, heck with you, just send me an empty sequence. One of the interesting things here about this also is that from a I/O standpoint, I want a sequence coming in, because that's the way you want to do I/O, and then in functional programming, you just want to sequence the stuff and process the sequence. But from a threading standpoint, if you're sending a file to me across a pipe, I just give me the whole thing. And that's because I got a limited number of pipes. Technically, I could set up more pipes, but for all intents and purposes, I have a limited number of pipes. I have a limited number of threads, and whatever you got, give it to me. So that was the console in send me the file stuff. Yay, fun stuff. Other thing that was cool here was I used a mutable. Woohoo! Mutables are what normally, I guess, imperative programs would probably assume to be a variable. It's something you can change the value of. You don't use that. That's ixnay on the variable aging for functional programming. But in this case, I actually thought I probably needed one. And the reason why is that if you followed along with the last video, I had to set up a thread, and I had to create a cancellation token and send it back, and it runs by itself. It's all very exciting. It's quite complex and fun. But how do I know whether it worked or not? And from a bash standpoint, from an OS standpoint, I need some sort of integer code to tell me whether the thing worked or not. So in this one case, I think it's okay to have a mutable cell on this thread here, because this thread actually pops into the main code on the utils file we'll look at next. And once that's done, it sets the ret variable, and it doesn't change thread. So I'm not actually calling across a thread to change a variable, which is very bad. I don't think F# would let me do that. At least I hope it wouldn't. So when we call the new main, we give the arguments from the command line, get the context token. We've got the shim that lets me shut down the threads. I have the stream, which I just brought in, and then I've got the reference to the mutable cell. Let's pop over to the utils file for EA, and this would be in source EA util, I think. Yeah, I'm still working on my code build debug cycle. I don't think I've used a debugger yet. I was just thinking of that the other day. I've been so busy logging and making sure the logging worked, and I actually have yet to hit F9 on anything to see how debugging works in .NET Core. Should be interesting to try. Maybe we'll do that next time. Still have my input stuff and the do stuff and output stuff we talked about last time. I had to create actually a type constructor that changed types. We'll talk about that in a minute. That was also fun. And what else do we have? Have some commented out code. I know my friend Bob would beat me for this, but I like leaving the comments in for a while as a way to remind myself of what I was thinking about before I took them out. Yes, version control is a wonderful way of doing that. Yes, you can leave this in and become a mess, and it's very bad. And ooh, don't do that. I'll do it, but you guys, it's bad for you. Good for me, bad for you. Output stuff. Oh yeah, one thing I did put in was one of the parameters in the supplementals in the file we didn't look at earlier, but it's in there, is the fact that the model should be able to eat itself. So whatever it comes out of this compiler, I should be able to feed back into the compiler, and it should produce the same results. That keeps the compiler honest. And so I actually did a little loopback test right here, and that was actually the first test I wrote for this. It wasn't a test. This is the program as part of production tests itself, and it should not run if this test fails, because it tells it's creating something it cannot consume later, and that's very bad. So it has a test built into it. Right now, let's see, what do I have down here? Here's the new main where I received all these variables we talked about earlier. Here's where I set the mutable value here. Boom. And then this, for you guys who like piping, this is send it all to this, and we're done. This is the actual code, 111. And that calls the methods we looked at above. I changed my outside try catch stuff to handle the ret value. So in case there's an error, it sets the cell. And also raises the event. I believe this has also been tested as part of when I put stuff in. And that's it for util. Next up is EA type extensions.fsi. So I started using my first FSI type signature files. Not something I used a lot of in the past. And if you followed along on my Code F# Like a Dummy series, one of the things I keep talking about is trying to keep it as simple as possible. And to do that, I don't mind sharing, and I do. I share a couple files that contain types I use across executables. And as long as I've got smart constructors around those types, and I control through my function signatures what can be created or not, I won't create something I can't consume, even though they're in separate executables. And I'm happy with that. Works for me. It's very easy to do. Keep life as simple as you can, guys. However, now that I'm actually put the core compiler inside a DLL, which is called ealib, well, now I actually have to pull types out of the DLL and use them here in the exe, and also use them in the testing code. Well, .NET was quite upset at this. For me doing this, it was saying type foo in this library is not the same as type foo in this library, even though they were the same identical code in the same file. And of course it makes sense, because from .NET standpoint, it doesn't know it's the same file now. It just knows it's the same name in different compilation units. That doesn't mean anything. And because of information hiding, encapsulation, it doesn't know. I'm not supposed to know. And so at this point, it was either start setting up some dynamic reflection-based blah, 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 and why? Instead, what I did is create a signature file. Signature files in F# are like header files in C, if you use that. It's the way I understand it is that if you want to tell the type system, boom, this is what I have, don't do anything but this, make a signature file, and then it'll restrict to that instead of trying to do the Hindley-Middler type inference stuff. So it's not something I would want to use everywhere, even though I understand lots of folks do. For this situation, I actually need two types: my compilation unit, which is just an array of file contents and infos, and my compilation result type, which for now is just an array of strings, because it's just going to kick out a bunch of strings that are going to be printed or something, I don't know. So I have two types, and then I've got, what else do I have? Well, I've got my logging code. I'm not sure that belongs there, but I left it there anyway. I could move my logging code out to the DLL now, and then I could run it, because DLL is executing process, and 6 of one, half a dozen of another. Something to think about. I don't know. There's no reason to make one architectural choice over another. It's kind of one of the other things the book gets to. The only reason I put anything in a piece of code anywhere is because behaviors and supplementals come together to create a testable condition for me that requires that structure to be there. In most cases, guys who code just make up their behaviors and supplementals in their head, and they don't ever say them. Like, oh, I really like this to look like that thing I saw on Slashdot or whatever. And so that's what their structure is driven by, and that's fine as long as you know that. So that's one of the reasons I've tried to call out every time. Okay, I'm doing this because it looks cool. I'm doing this because I'm being explicit about my architectural choices, and they're arbitrary. They're arbitrary. Yes, some architectures are beautiful, some are but ugly. Users don't care one way or another. Code maintainers don't care as long as they can maintain it. Make your code be valuable first. Okay, that's type expressions. That's my type extensions FSI. And then we go to the utils FSI. This is the type signatures I actually end up sharing, which is this stuff. And then I had one function, which is compile. That's the thing I need, because I need from the test code and from the exe file, I need to call into DLL and have it compile. And it takes this stuff, sends me back that stuff. I do that. I don't go through and take all of my types and create signature files and no, just easy. Stick with Ma. Ma is minimalist approach, and Ma will look out after you. She loves you. She's your Ma. That's utils FS. Okay, so that's kind of all the structure, and then the reasons why the structure's there. Finally, we get to the test code. This is my shell test code. This is not a bash. I'm not going to bash, but this is not a bash programming video. The interesting thing to point out here was there was this string single quote thing from hell down here from lines 42 through 44. And basically all that does is take an empty file, stick it in this one file here, then it runs some other empty files, more empty files, and then verifies that they have nothing in them. And actually my test is broken here, so I need to fix that. But that's what it's supposed to do. So cool, let's I'm not going to run the build, but let's run the test here. My hotkey for testing works on my other computer, but doesn't work on this one. So go figure that one out. I'm sure there's a reason. I think it's probably because it's in the environment setting. Don't know. Don't care. run task, and there's my test task. Now I put in the no build here. Oh, what do you got here? Oh, okay, you can't. That's not going to work. You can't have see comments. There we go. In every demo, some rain must fall. Let's try testing again. Yeah. I put in the no builds here. Basically, after it does the bash test, which should print out a smoke test fail or pass, a smoke test pass, it pops down into each directory and runs the test exe. If you'll notice here, it runs the first, I think it's EA test. Beautiful thing, a little debugging and everything. Then it goes to the second directory, runs very, very similar code because I've copied this from one spot to another, and I get this, which is, oh boy. So to make things better, it runs finally on the other machine. And if you look at this in Git Bash, it looks beautiful. It has even little colors and stuff, which is very nice with the colors. It's very, very, very aesthetically pleasing. Why? I don't know. I don't know, and I'm just assuming that it'll work itself out through development. It's not something I want to spend a lot of time on. So those are my tests running. The stories work. We should look at the expecto test too, where there's at. This would be EA test in the util file. And then my expecto tests. Yeah, so I have to get a new fake file info object. Contents are nothing. Here's my parm parameter to call in to do the compile. It compiles it. It says, hey, there's nothing coming back. This is good. And this expecto does a much better job of this. I'm just sort of clowning it out right now. Then we do one command. It just takes one line of A. It checks to make sure the A came back. Then it does two files, one with A, one with B, and checks to make sure there are two lines in the correct order, A and B. So, and they run. We saw that they run. It's a very, very nice thing. So what's next up? Okay, well, that's a good question. I thought for my next stories, what I would do, and have this under E3 AMIN, I would recognize and sort lines by the line type. If you've looked at the documentation on the wiki, I have 6, 7 different types of line types. So that seems like a good thing to sort of start with. And I have some parents here that sort of join together, create test cases here that I'll actually code up. Then I have print out project to do items. Also seems like a very useful thing. I don't know if I can do both or not. I have no idea. I'm limiting myself to about 3-4 hours of work each time here. Let's find out what we got. And then at the bottom of this, my little thing here, I create a little to-do list. And I said, basically, I think I'll make a discriminated union to handle all the line types. Then I'll look into using fparsec to create the discriminated union with the text involved. I need to determine what I mean when I say print out. Do I mean like HTML pages that then print or just text files? We'll figure that out when we do it. I am my own product owner, which is kind of cool. And then note that this file is both sort of my little mini sprint backlog and the test data, which is kind of cool. So I'm just going to run this file through, and it should create a to-do list and my 2 user stories or whatever the thing's supposed to be. So here we are. Appreciate you guys dropping by. This has been a hoot so far. It's a little painful at first when you get the structure set up and you kind of get the system running. My tests right now are like dog slow. A lot of things I'm not happy about. But I am happy that I've got the framework in place to do some more building. And this is one of those things that the more tests you do, the more structure you put together, you just sort of start building up momentum like a snowball rolling down a mountain. And I know by the time I get 2 or 3 more episodes in, the thing's just going to suck me in. Some cool stuff ahead. I'd love to set this up so it synchronizes with Trello and all sorts of other things. You guys are going to like what we're doing. Have a good one. See you later. Bye.